All right, let's get right into it. We're talking about putting AI to work not just in some app or website, but in the real, physical world of manufacturing and operational technology, or OT. And this is a whole different ballgame. The stakes are just so much higher, because when something goes wrong here, it's not just a bug report. It can have serious, physical consequences.
This quote really hits home why this is so different. Think about it. In a normal IT setup, a bad software update is a pain, for sure, but you can usually roll it back. In an OT environment, we're talking factory floors, power grids, you name it, a mistake can mean a production line grinds to a halt, a safety incident, or an entire batch of product getting ruined. The consequences are tangible. You can touch them.
So how in the world do we handle this? Well, here's the game plan. We're going to start by looking at the huge divide between the IT and OT worlds. Then we'll lay out a blueprint for safety and climb what I call the ladder of trust, one step at a time. We'll also talk about the most important safety net you can have, look at some common, costly mistakes, and then wrap it all up with a clear mandate for anyone working in this space.
Okay, first things first. We have to understand why the old rules just don't apply here. The world of information technology and the world of operational technology might sound similar, but believe me, they operate on totally different principles, especially when it comes to risk.
And this right here is the absolute heart of the matter. In IT, a mistake is a data problem. Data gets corrupted, a service goes down. You can usually fix it by reverting some code or restoring from a backup. But in OT, a failure is a physical event. An AI telling a robotic arm to move an inch too far isn't a data glitch, it's a potential collision. You can't just hit undo. You have to physically stop machines, check for damage, and make sure the whole area is safe. This one difference is exactly why we need a completely new playbook.
So, if we're throwing out the old IT playbook, what's the new one look like? Well, it's not just one simple trick, it's a whole framework. You should think of it like an architect's blueprint, designed from the ground up to govern every single action an AI system might take in the physical world.
And here is that blueprint, the IT/OT control plane. Now I know it might look a little complicated at first glance, but the idea behind it is actually really simple. It creates three critical layers. You've got a control plane on top setting the rules, an execution plane in the middle where the actual IT and OT systems do their thing, and an evidence and audit plane on the bottom to record absolutely everything. This structure is what gives us the control gates and the audit trails we desperately need. Keep this image in your head because it's the foundation for everything else we're about to discuss.
Okay, with our blueprint in hand, we can finally start talking about deployment. And the best way to think about this is like you're climbing a ladder. You don't just leap to the top. No way! You earn your way up, one rung at a time, by proving with hard evidence that the system is trustworthy and safe.
These are the 5 rungs on our ladder. We start super safe with the AI just giving advice. Then we let it make recommendations, but a human has to sign off. Then we'll test it secretly in the background, give it a few tiny low-risk jobs, and only then do we gradually expand what it's allowed to do. Each step is carefully designed to keep risk at an absolute minimum while we build confidence in the system.
So, let's step on to that first rung, advisory first. In this stage, the AI is basically a consultant with read-only access. It can look at the data, and it can offer up ideas, like, hey, here's a way you could maybe optimize this production line. But it has zero ability to actually do anything. A human has to take that advice, think about it, and then decide what to do. This is the perfect, absolutely zero-risk way to start any pilot.
All right, next step up is gated recommendation. Now, the AI can come up with a specific action, like we should prioritize maintenance for machine B right now. But, and this is the key, that recommendation hits a hard stop. It goes to what our blueprint calls an approval gate. A human operator has to look at it and give it an explicit yes before anything happens on the factory floor. Every single one of these decisions is logged, which gives us that beautiful, clear audit trail.
Now, shadow mode is probably one of the most important steps for building real trust. Here's how it works. The AI runs in the background, making decisions just like it would if it were in charge. But its outputs don't actually go anywhere. They don't touch any of the physical systems. Instead, we just watch and compare its decisions to what the human operators are doing in the real world. This is our #1 way of gathering cold, hard evidence. Is this thing making good choices? Is it safe? Is it effective?
Only after we have a mountain of evidence from shadow mode do we even think about taking the first step into true automation. This is a huge milestone. It's the first time the AI will have a direct impact on the physical world. We call it limited scope execution. We give the AI control, but only inside an extremely narrow, super low-risk sandbox. We define its boundaries, we watch it like a hawk, and you better believe we have a pre-planned rollback strategy ready to go at a moment's notice.
And finally, once a system is mature and has been validated over and over, we get to staged authority expansion. Now, this is not a free-for-all. It's not like we just flip a switch and let the AI run wild. It's a formal process where you increase the AI's scope in these very deliberate, pre-approved phases. And after every single expansion, you have to go back and revalidate its performance. Trust here is something that is continuously earned. It's never just given away.
So we've climbed our ladder of trust. Great. But what happens if a rung breaks? You'd never climb a tall ladder without a safety net. And in our world, that safety net is called rollback.
This is the question. The one question that every single team must have a rock-solid answer for before they deploy anything. Hoping for the best is not a strategy. You have to have a plan for failure, because in a physical environment, the cost of being unprepared is just way, way too high.
Let me be as clear as I possibly can about this. Defining a rollback procedure is not optional. It is a non-negotiable requirement for every single one of the deployment patterns we just talked about. It has to be designed in from day one, not slapped on later as an afterthought.
So what does rollback even mean in an OT world? We're not talking about just reverting some code. It means halting physical processes. It means switching the entire system back to full manual human control. Or it could mean hitting the big red button and executing an emergency stop. If you remember our blueprint diagram, this is that emergency rollback authority path, a direct, immediate line to stop things safely.
Now that we know the right way to do things, let's spend a minute on the cautionary tales. These are the common traps that teams fall into when they don't respect the simple, physical reality of OT.
These are the cardinal sins of AI and OT. Skipping shadow mode, that means you're flying blind, deploying something with zero real-world evidence. Assuming an IT rollback will work, that's a recipe for disaster when physical machines are moving and reverting code does absolutely nothing. Expanding the scope without revalidating, you're basically gambling that what worked in a tiny test will magically work at scale. And deploying without a tested kill switch, well, that's just plain irresponsible.
Okay, let's bring all this home and wrap it up into a clear mandate for any team working with AI in these incredibly important environments.
It's really, really important that we're all on the same page here. What we've talked about today is a framework. It's a way to think about deploying AI safely. It is not an authorization or a green light to go automate any specific process. That decision to automate something in the physical world carries immense responsibility, and it has to belong to the operational teams on the ground.
At the end of the day, our goal here is to get you into the right mindset. The one guiding principle that runs through all of this, from the IT/OT difference to the ladder of trust to the need for rollback, is a deep, fundamental respect for physical reality. That is how we make sure things don't go horribly wrong.
So I'll just leave you with this one question to take back to your teams. Look at your own plans for deploying AI. Are they deliberate, with crystal clear intent and boundaries? Are they staged, earning trust step by step with real evidence? And maybe most importantly, are they reversible, with a tested, physical safety net ready to catch you? Answering yes to all three isn't just a good idea, it's your mandate for moving forward safely.